And when I looked at what Jim had done, lo and behold, there, though he hadn't put it in, there was this isosceles triangle. In other words, something had come out in the base pairing, which of course fitted Chargaff's rules, which he hadn't put in. And it was from that moment, I think, we knew that we had it. Well, from then, of course, the next step was we had to build a model with the coordinates to show that it was acceptable, incorporating all the ideas, the phosphates on the outside, the base pairs and so forth, and that's what we proceeded to do. The reason we had to do model building was that although we had the basic idea of the structure now, namely that the phosphates are on the outside and we had to put in base pairing and so on, we still had to show that we could build a model with acceptable coordinates. When you build a model to see if it's going to be acceptable, you don't build something like that. That's quite unnecessary. All that's necessary to build is one residue, one bit, because if you get that right and you've got its relation to the next bit right, as it were, you can just imagine the rest of the model, or mathematics will generate it. We didn't even use a base pair. We just used this much here. That's to say half, because I worked out a theorem. There has to be the diode axis here. I worked out a theorem such that as you move things around, there was a constraint, and if you built this half right, then this half would automatically come right as well. So the amount we built was just one residue, but you had to have one atom repeating, say like this phosphate. So you had a phosphate, the sugar, and one base, and you had to make sure that the relationship between this phosphate and this phosphate was what you wanted. That's to say, up 3.4 angstroms and round the 36 degrees. The aim we had was not to get the atoms in the right place, but to show that at least one version of the model could be built.